The way that JAGS is calculating DIC is a little bit more, actually a lot more complicated than the way that bugs is. Like the difference of 19, right? So it's progress in research, but it's just not easy. So, no, we're going to go with the posterior predictive check on this. That's a fail. Model fail, right? So how about we do a two-factor model? Lisa has probably a better model.
Yeah, it takes 2 bypass.
I'm going to run this model, and we're going to see how well it does. It's probably going to fail too. 2 additional factors. So there's 3 factors in total in yours.
Oh, okay.
It's a specification workload. Up to 2.
But we'll talk about that later. Let me get this model first. This you think could be a 2-factor model? Let's see what I did. Don't I know what I did? I did at one point.
It was like a month ago.
Yeah, it was. So here is sort of what I ended up doing. So x factor is my factor variable. Lambda is now a matrix. So lambda is 2 columns by 10 rows. So 10 items, 2 factors. And so I have item 2, 7, 8, 9, 2, 7, 8, 9, sorry, 2, 5, 7, 8, 9 are on factor 2. And the rest of them are on factor 1. And why did I do that? Government versus not. So if you look at these items, item 2 is something about government. Are you worried about government versus general conspiracies? That's sort of where I was going with it. Right? So U.S. or vapor trails left by aircraft are actually chemical agents. Government officials, right? 8, government officials. 9, governments are like U.S. invasion of Iraq. Well, I guess that's sort of government, but it doesn't specifically mention government. Right? And then it talks about oil companies and other people. Government, I think the deep state, right? Those of you who don't know what I'm talking about, you don't need to. In fact, it's probably best if you don't learn it. Yeah. Although I guess you could maybe claim that. Sound plausible? Like, conspiracies about the deep state versus conspiracies about other. So how do we code up the 2-factor model? That's that for your homework. It's not a 2-factor model, it's a 3-factor model in your homework. So that's where we're going to specify our model. Again, the factor model now, each item only has 1 factor loading on it. So it's not going to be overly complex items. So each item will have a factor. On item intercept, which I'm calling mean here, actually mu, each item has a lambda of some sort. Each item has, that lambda multiplies one of the factors. And then there's a unique variance for the item. So those are all the same parameters that we saw before. So for each item, they're the same number of parameters, the same number of item parameters we had in the model before. Only now, with 2 factors, we have to worry about the distribution of the factors themselves, right? And that's where item means, item variances, item unique variances. So now with 2 factors, we have to think, okay, we don't use a univariate normal distribution for these factors because then they would be uncorrelated, and that's bad. Not likely to fail. So they do an EFA, right? Started. I threw a pen the last time. You weren't here, Ben. Ariel asked the question, and I was like, maybe we'll get to that. We'll get to why that was. I may throw a pen again or something. Spill coffee all over my computer. Anyway.
This is why I come to class.
Yeah, just
to talk about the Illuminati deep state and watch you just throw things.
What have you learned in this class? Well, something about Bayes, but conspiracy theories were really amazing.
I know Bayes is Bay, and that's about it.
Bayes is Bay. There you go. It's B-A-E-S. Okay, 2 factors. Multivariate normal? Right? Multivariate normal? Yes, multivariate normal. Let's do that. So then the question would be, what's the factor mean going to be? What's the factor covariance matrix? because that implies kind of sort of scale identification. I think that's the word I've been using for it. Scale identification means we have to, for the factor means let's just set the mean to 0. That seems pretty customary. That's a straightforward extension of how we did the marker item variance last time. For the variances, though, variance covariance matrix, we may want to start with the correlation matrix, right? Wouldn't that be something? However, correlation matrices are nearly impossible in DAGs to get to work. You can, but there's two that would work the best. The correlation matrix, that means the diagonal is the variance of the factor, and that would basically say we're standardizing our factor, right? So we're not going to estimate the variances, we're going to fix them to 1, and we're going to estimate the off diagonal, which when they're both 1 means it's a correlation. So we could set up for 2 factors and 2 factors only. We could set up the case where our factor covariance matrix had only one the off diagonal element, the 1, 2, was estimated, was the thing in the chain. Now it's a covariance, we could set our correlation, since we know the range of it, we could go and put a uniform on it if we wanted. We could put a beta, rescale a beta higher. For covariance matrices, or correlation matrices, anyone want to guess why? It's not just the level, it's not just the...
I'm really good at simulating.
All right.
Oh, okay, sure.
That would be non-positive depth.
Like 0.5.
No, 0.5.
0.
Uh-huh.
And 0.9.
So what am I saying with a non-positive definite? I mean, this matrix would not be invertible. And with that, we would run into some issues, particularly when we would want to, well, actually, the likelihoods are all expressed in inverse correlation, so we'd have to invert it every step to make it work. So let's take a look. I've just built an example matrix right here. I'm going to guess. Okay, how many of you think this is non-positive definite? We're gonna put Lisa on the spot here. 1, 2, 3, 4. Anybody else? 5. Anybody says you can invert it? I will say you invert it. This is invertible. With 3, it's actually kind of hard to find.
Oh, I can do it. Maybe not this one.
Ta-da!
No.
Or better yet, let's do this. Non-positive definite should have eigen... Oh, wait! It's non-positive definite. She did it! It allows us to invert it.
It's not the exact same thing that non-positive have all positive eigenvalues.
It's determinant.
It's one of these things like multicollinearity, how we use it, not really what it means. This is...
The determinant.
The determinant, exactly. The determinant is
So, she did it. Point being, that would be bad. The other one I think you can do is something like this, where 2 are very positive and 1's very negative. There we go, right? That's really... So, why am I saying this? Because if you think what's happening in the chain... Sorry, you were going to say something.
You could add, what I have introduced a determinant analysis, and I have a function that will check if it's semi-positive definite or the current positive definite. And if not, we round it to the next closest semi-positive definite.
We don't want that.
But the issue with that is that it's not a unique solution either.
Not so you're talking. So we propose a new. We're going to use Metropolis Hastings for this because there's not a Gibbs sampler for it. When we propose a new covariance matrix and we do your solution, we don't know the likelihood of transition, so we couldn't come up with the Q factor in there. But if you're really interested in this, if we're going to dive into the weeds a little bit, in grad school there was a paper that came out in the 90s, I think, in Statistica Sinica, like an Indian statistical journal, right? And they talked about how you could make, for any element of a covariance matrix, or correlation matrix, correlation in this case, you could show that the conditional on all the other, right? You could show what range this would be to make it positive definite, and it was actually a parabolic, like a quadratic function. And depending on the signs of things, it would be either convex or concave, right? Or concave, convex, convex. Look at that now. Sorry. I'm having a hard time with math.
Happy or sad?
This is concave.
You would say concave now.
That's what I thought. That's what I was trying to say. Convex. So what I'm saying with this is you'd just effectively be able to find a sampling range for each element if you went element by element through it. And I build algorithms that have done that. But doing that in JAGs is almost impossible because now you have to. The hardest part with JAGs, you can create truncated proposal distributions in JAGs that are truncated off of fixed limits. But I found it very difficult to do more than a couple parameters where they're truncated off of other parameters. And this truncation would depend on another parameter. So it's an odd thing. Other people have tried where they don't generate the correlation matrix, but instead they generate like eigenvalues, or they do some type of decomposition that they're generating. But long story short, if you want correlations in JAGs, hard to do. Bordering on impossible.
I have seen, and if I'm taking you too far away, just shut me down. I have seen also people assuming that they're getting the correlation matrix and saying, okay, now the standard deviation for these variables are these, and they
rescale it.
And they scale it as it were a covariance.
I have seen that as well, and that may be possible, but I haven't worked through the math on it. I want to like address the parameters, not some other way around with it. So, can be done. I don't care to do that. What do you think, everybody? Questions? So what were the roadblocks with correlation? Number one, it's not easy to be put into a Gibbs sampler. If it exists, I'm not aware of it. That doesn't mean it doesn't exist. I haven't seen it yet. And number two, rescaling would depend on. So we have to do. Oh, sorry. The number two thing is even if you element by element priors that would work, you do a Gibbs sampler, you will quickly run into places that you can sample non-positive definite correlations. And because to take the likelihood of the data, or the likelihood of the factor in this case, the way that JAGs works, it's DM norm. This is an inverse covariance matrix. You're sampling correlations. You've got to go and invert it. Or you got to figure out what the range of an inverse correlation matrix is. A nightmare. So.
What I was saying, as bigger the dimensions, that dimension, the more the complexity to be able to get a positive inverted one.
Oh, it's really going to be hard. Yeah. So my advice is just stay conventional IRT, where I fix the discrimination parameter. I don't often talk about that in IRT class. Same thing we did for the univariate case with the saturated model. And that's sort of the reason I dwelled on that in the saturated model too. Is a real direct covariance matrix. So here, what I'm going to do is take a factor covariance matrix, because we have two factors in this example. I'm going to basically say the prior for it is an identity matrix. Diag 2 gives us just a matrix with ones down the diagonal and zeros at the off diagonal. I actually started it, I tried to see how things work with other things, but I commented that part out. The inverse of this, the inverse of diagonal matrix, is just the diagonal matrix as well. So, inverse of, sorry, an identity matrix is the identity matrix as well. I should say diagonal. So, degrees of freedom are 2. That was the way that we had come up with before. And now let's get into the syntax in JAGs. Before, we had a loop that went over all of the items. When we specified this item likelihood, this was present. Right? We said each person's data, and this is the model data likelihood, follows a normal distribution, univariate normal for each item, with a mean and a inverse unique variance, or psi value, right? So when we had done this, you'd see right above that, the line had one of these items specifically. And the way that I coded this, there's probably other ways of coding it that are probably a little bit better on the code side. but this was more to try to do a teaching example. I took all 10 items and have its own line. And then I gave the item, basically the mean side of the item equation for each item so that I was allowed to vary. So now, again, lambda is not a vector, not a 10 by 2 matrix. So zeros if lambda was not there, the item was not. Right? So here, lambda, the first item was for factor 1, so lambda 1 shows up, multiplying the factor for the first with the value of 1. And once again, I put x in front of factor because I want those at the bottom of my output, right? I don't want to have to change my options to get it to display all of it, so I put that like at the end of the alphabet the guidance output. So then for item 2, because item 2 is one of those other factors on factor 2, lambda 2 shows up with factor 2. Okay. So this is how it works. Does that make sense? Any questions? So later on, the prior distribution for the factor now is, this was d norm before, but where it was unidimensional, but now it's multidimensional. So it's dm norm with some type of factor mean and inverse factor covariance matrix. The factor means were fixed to 0 right here. And the factor covariance matrix, I should have put this closer to the other statement, but this turns out to be inverse Wishart. So we said, here, let me go and put this closer to that covariance term. So basically, fix the factor means 0, but this says estimate the inverse covariance matrix of factors. So this inverse phi is going to contain a 2 by 2 matrix, the diagonals of which will be the 2 by 2 matrix, that's the inverse covariance matrix. If we wanted to actually see the factor covariance matrix, and we're going to do that later on, I'll have to use the inverse command applied to this thing to get the factor covariance matrix. Now, I will say computationally, one of the nice things about why they code things with the inverse covariance matrix in JAGs is it saves you from having to invert it at each step of the chain, which is not only a bit time consuming, but it's also one of the more operations if you do numerically. So the fact that it's just sampling based on inverse allows us to get away, to save some numerical precision with it. Now I will go and convert it. I will go and convert it to an inverse. I'll take the inverse of it, but it's not using that calculations or the likelihood functions. Right. Questions on this?
The prior for the factor covariance matrix, is this an approach to?
That's where I was looking. You can.
We know we don't want it to be diagonal.
Right. So the inverse Wishart, I said this before, inverse Wishart, there were these spikes at the end that sort of looked like numerical precision issues, but it looked fairly flat in between for the correlation. But that's your certainty. We, as people, do we believe there should?
I can't search.
Thanks, Siri. Hey Siri, what's the prior for an inverse Wishart?
Sorry, I can't search the web on Apple Watch.
Dang it, Siri. Anyway, if we as people were thinking about this in more of a Bayesian flavor, would we ever want to pick a 0 off diagonal for the factor covariance matrix? Is that really appropriate for psychometric data? Never. Pretty much everything that you're going to find that comes out of a person's head that we're going to test, we're going to have a correlation. There's been papers, if not hundreds of years. Lloyd Hemphreys, he was emeritus when I got there. He came to work every day in his late 80s, right? That was his deal. But he, in his office, you wouldn't find anything correlated less than 0.3, let alone, most likely when you do this, when you run CFA, 0.6, 0.9. I've seen 0.9. Yeah, I'm serious. I mean, things get really highly correlated, particularly if the trait's really nuanced or somehow not there. Then you get in that spot where where is it effectively one trait versus two, and you know all that other stuff goes along. But point being, real Bayesians, maybe we wanted to be capital B Bayesians. Our prior belief would probably be set different than an off-diagonal on limit of 0, right? Does that help? Awesome.
That's to make it uninformed.
0 is to make it uninformative, do the least amount of harm. So what we're trying to set this up to be that even though we expect it to be positively correlated, we don't want to sort of influence that yet. So.
Otherwise, you're probably going to pick the ML sample correlation, and that makes you feel weird too.
Right, yeah. What are you going to pick? I mean, I tried to, this is where I commented it out, but I started with 0.6. Not a factor correlation of 0.6, but even that's, well, why 0.6? I don't know. So, other questions on factors? So once again, in this syntax, items are mostly the same, although I had to, the factors we have to go and put the multivariate normal in. So that causes us to have a Wishart distribution for the inverse covariance matrix of the factors. And then when we get down to the bottom, this is where we can put prior distributions on the item parameters. The mean and the unique variance, these are identical to what we did in our previous example. Even the same values of the hyperparameters. Remember, hyperparameters are the parameters of the priors. Okay. When we get to lambda, I specified it differently, and that's because some of these lambdas have to be fixed. Some of them have to be 0, and some of them have to be 1, right? So upon, you'll note I did not put any zeros in here. And that's because when I input my data into JAGS, and I have it basically the starting value at 0, it will stay at 0 if I haven't specified it anywhere. So here, I'm going to put a 1 to standardize, or to put a marker item on each dimension. And arbitrarily, following, I feel like it's practical convention, although I think it's, again, arbitrary choice, I just picked the first item that appeared for each dimension, meaning item 1, which was on whatever dimension 1 was, general conspiracy, got a 1, we're not estimating its loadings. And then item 2 was on governmental conspiracy, we're not estimating its loadings. And then, of course, I have 0.1s down here. This should all be the rest of the items that show up, separated them out by which dimension, but they all follow the same prior that we had in our unidimensional example. I'm sorry that I had a 0.1 there. That would have just been the lambda position. This I moved up to the top. And then finally, I'm going to go and convert within the chain. I'm going to convert each unique variance for each item, the item parameter unique variance, to regular. It's inverted, right? And then I'm also going to take the inverse of the factor matrix, get back to the regular factor covariance, and switch this matrix right along. And that's what I'm going to set. Questions?
If this were a bifacial model in which factors were forced to be uncorrelated, would you do them like you do in unique variances?
Yes. Yes, I could do that. Where the diagonal of the matrix is estimated and the off diagonal are all zeros. Yes. And degamma. We can do that. Have an example. Questions? Comments? How's the pace? Okay. So we have all this stuff there. So I'm going to most of this. I'll note the data itself does not change because we just still have the inputs, the same inputs that we had before. Although we now have this factor inverse covariance that shows initial values, saved parameters, using the model itself. And believe it or not, oops, I used R to JAGS for it. This was actually, so I got tired of having to put all the stuff down that I needed for R JAGS. So I just used R to JAGS here. Why don't I like R to JAGS in general? like argjags is a positive because you can get to your results much faster. You have to specify less stuff. I haven't gotten argjags to give me the same result for the same seed though, and that's a problem. So, right, right. I'm glad. Thank you. That was like a dramatic. That was good. Really? Yeah, not good, right? I do reproducibility. You kind of want to be like, let's keep that. You know, when you're in philosophy, shouldn't we like? We do want to teach you, but the ideal should be, hey, when you do science, someone might want to check your result, or you might want to check your result. If you're in a lab and someone runs on it, right? I've heard that you do this with your students, so it's good. Anyway, but here we go. Here are all of our. No, so the first question I should have asked. Well, in R2 JAGs, they on the summary, which is nice and convenient also, right? It's quicker. And all we want this to be, but anything that's under 1.1, I like. 1.1 to 1, and you can take a look, these numbers are close to 1, like 1 lambda is a little off. They're all pretty good. So I won't plot them. But now, that we could also, so a couple things with this. When you run the two-factor model, if you want to see the correlation matrix, you've got to go form it every step of the chain, right? So what is it? How does it work? Not quite sure. Second, model fit. Well, we can compare model fit with other models. That model fit doesn't look at 6,800, whereas the other two we were at was 3,900. So it's saying this is much less effective. Does it fit the data? We'd have to do a posterior predictive check for it. I didn't put the code in there. I want you to think, how do we do that? I can lead you through an example after the break if you like. Or we could talk about some other type of method. What do you think? Questions on this? It converged. We don't know if it fits. Why I'm saying this to you is because you notice how I had to build a posterior predictive check syntax before. A lot of times when you're building a posterior predictive model check, you're kind of stuck to write your own syntax. There are people who have written it for you in other packages, but most of the time, if you're going to do JAGs or some other type of pure, like low-level access the likelihood yourself, and that syntax yourself is going to affect the way that you build your posterior predictive. In fact, I'll lead you through. On that note, though, how many of you are finding this really, really tedious?
Yeah.
Tedious. Lisa, is it tedious?
I would put that in.
So, I have a friend from grad school. He went to Illinois 1 year, and then he moved to Ohio State. He created a package called BLOVON. There's the LOVON package, which does latent variable analysis in R, which basically tries to mimic M+. So you can imagine what LOVON does. It's Bayesian LOVON. Yeah. There it goes. Now it works. So you can quickly specify a model in BLOVON. I'm not giving all this like the easy for you, because right now the state of the field with other people's packages is sort of very scattered, right? M+, you can do estimator equals Bayes, but then you've got to figure out how M+ is doing Bayes. BLOVON, you can sort of start to figure it out. Actually, what it ends up doing is converts your LOVON-style syntax to either JAGs or stand code, depending on what you specify. Figure out and see that quickly. It's providing an easy syntax mechanism to give you syntax for whatever you want to use, JAGs or stand. And there's a lot of other packages for this. Brandon was talking about for the linear models one. What was it? BLME, BMRS, right?
It seems here you have to dig in and see what priors they're using.
That's it. So watch what happens though. let me just show you what happened the first time I used Lavon. This is the syntax. Factor equal tilde is like m plus's by command. It says anything on the left of it saying defined by the factor, which by the way drives me nuts because it makes you think like the nature of the arrow is the opposite direction. That drives me crazy. Anyway, and then this is saying you want to estimate the factor variance. So I put this together. Run JAX. Oh boy. I wanted to show you this because when you think, hey, it's going to be easier, that might be the case. Look, it's running. Look at that. It's adapting the model. It's burning in. Dun, dun, dun. This is going. Let's go. Let's go. Running the model for about 10,000 iterations.
It decided that.
It did, right.
These seem like okay numbers, though.
And I think he's put a convergence checker on there, so if it hasn't converged, it'll run a little bit longer. So awesome. One of the things that Lavon does well is if you were we talked about the problems with covariances and what we did. If you have residual covariances on your errors, it's ridiculously hard to get those to work because they're scattered, and you can throw off into identified or non-invertible Psy. Set up a way to make this work. But see what he's ended up doing here at the end. He's computing posterior predictives of the pack. At break, I will tell you if I don't want to.
The more I see this run, the less I care what problems it. This is pretty cool.
But wait till you see the results. And I hit summary. Huh. Oh no. My estimate. So it's giving you Lavon or M plus style output. Estimate posterior standard deviation. It gives you highest density predicted. Look at this. This is your Gelman-Rubin R. What happened? Modes. So even that has its problem. And if you're running it here, like to get, okay, I ran this. What the hell happened? This is like off-the-shelf factor model stuff. What? It should have.
Where is Fragment when you need it?
I know. So all of a sudden, it's bad. Come on, Ed. Actually, Ed is one of my favorite people in the world. He's really cool, and he does really good science. And so I follow his stuff quite a bit. I don't have any bad things to say. This is the point of this, though, is that I'm trying to say I was going to do all this tedious stuff, and I was going to end with Lavon and be like, look, it makes it easier for you. Bless you. It's rarely that case where it's easy.
Is any argument that you can add in the function that will help you with the multiple?
Like, what do you mean?
I don't know. I wonder if how you did your fix for the multiple modes. If I was wondering if you have an argument that you can put.
Not an argument, but you can do. You can. There are ways that knowing about this allow you to fix it. For like initial values, you can initialize them. Right now it's as simple. You could do m plus. Like for instance, if I did init equals m plus. M plus. So when you write your own package to sort of do Bayes in front of everybody, you have a lot more control of this. And if you know the typical use case, like for us, the single factor model is a pretty typical use case. Make sure I spelled this right. Init m plus with a lowercase p. Let's try that.
Does that mean do what they do?
Yeah.
Or just use the ML solution?
I think they're using the ML solution. I think that's what M plus does. I don't know. Let's see here. and you can give it a regular ML solution as well. So, point of the matter is, like M plus, I'm going to try to complement it now. Even though you can't see what's under the hood, they sort of know the typical use case and certain patterns with this. So if I'm programming my own Bayes algorithm for this, I'm going to make sure the starting values are all in the same direction. But let's see if this works.
But you're telling me that this is in much more languages now?
I don't know. It doesn't.
Okay.
I don't know that I can. It says what it is. In the first two cases, via ML. Yeah, I don't know. So, short plus, it still broke. So, and then if I did, let's see this. Let's just do the ML version, which we're a Bayes class. So Lavon gives me solutions that are in the right direction. So again, if you're going to build, if you're looking for relief on the Bayes side, the problems I have with M plus are that you don't necessarily know what's under the hood. Maybe if you go a step further, plus it costs a heck of a lot of money, but they're able to do that because they made it easy, relatively speaking. Haven't quite gotten there yet, although I think pretty good you have to build, but you have to have the knowledge going in, and that's why the tedious is here, or motivating what we did. Sorry, my big golden example, because it's computing posterior predictives for you, and I'm like, thoughts? How many of you are likely to do Bayes in your life? That's good. How many of you want to do research in Bayes? Oh, I'm glad. Testing you. Nah, I wasn't a test. I was trying to oh, well, we should talk. It's not a bad thing. I think I was mentioning this yesterday. There's some research topics I want nothing to do with, and it's like, you know that? It's totally cool. It's particularly when you do a dissertation, you want to make sure that you love the topic when you start it, because if you don't love it, the process of dissertating makes you hate whatever topic you're at. If you don't start on a really high point, getting it finished is really difficult. All right, let's take a break for 10 minutes, and we'll come back and we can go one of two different ways and go from there, okay? Thank you.